The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
This is this video that we saw by David Mandela is about his new book, which is called Robots. Are robots ourselves, robots and the myth of autonomy? And he means exactly that autonomy really is a myth and will be so. And David has a unique perspective on this question because this is his life. In other words, he has been deeply involved with robotics at just cutting edge levels for the last 30 plus years. So he was deeply involved in a lot of the early undersea exploration, working with Bob Ballard and Alvin and the pods that came off Alvin. And then he did a lot of work with NASA and was involved in the robotics on Mars and the planetary explorations using robotics. And then he spent a lot of time working on he spent a lot of time with the US military that have been doing drone technology and has real hands-on feel. He's also a pilot and flies extensively, both helicopters and aircraft. He's been involved in a helicopter drone company, so he knows exactly what those are and how they work. And in addition, he's just taken leave from MIT, and he set up his own robotics company, including with people from Lincoln Labs, which has the greatest radar expertise. And the issue there is, how do you create robots that can work in really intimate proximity with people, right? Not kind of arm's length distance, much less locked in on the floor, but really in close proximity. So they're developing interesting technologies to enable that. So he's got a whole personal sense of what this robotics movement is all about. And he kind of takes us back from the literature that has portrayed this kind of ongoing nightmare of job displacement from robotics, and I think frankly puts us in a much more realistic posture of what it's actually going to be like when robotics start to scale up to a greater extent than they have so far. And his work, we read J.Z.R. Licklider when we took up the book, The Dream Machine, his biography by Mitch Waldrop. And Licklider, as you remember, gave us this picture of how people and machines were going to work together. And Licklider, in a way, was responding to a period of technological concern that computers were going to replace people because they could think better than people. And Licklider, although a great technologist, was trained as a psychologist, and his field was man-machine interface. How do people work with machines? How does that actually function? And so he comes to computing with this vision of a symbiosis between computers are going to do what they're good at, and people are going to do what they're good at, and we're going to have a symbiosis between the two that's going to optimize both territories. And indeed, that's exactly the direction that computers go in. In other words, I'm not spending sleepless nights wondering when this thing is going to replace me, right? We thought it was, right? And Norbert Wiener at MIT had invented the term cybernetics and wrote the first book on the topic. But Wiener had a very dark vision of what computing was going to be for the future of human thinking. It didn't turn out to happen. So Mandela is arguing that even the most threatening technology, which arguably is robotics, it's just not going to work out that way. A symbiosis is going to be what's achieved here. So he takes apart each one of these territories in the book. I mean, I had you do the video, but it's a very rich and very well-written book that's a tremendously fun read, and he tells a lot of great stories. But his vision is that there can be a richer space when people and robots are joined. There's a richer understanding and ability to make perceptions and judgments that occurs from that mix. And that turns out to be exactly his experience undersea and doing space robotics. That there's just a different kind of environment that evolves here. And it's better than a machine alone or a person alone, that there's a new symbiosis that enhances both sides in a way that we can draw on. And what he finds is that when people, in effect, start to operate the robotics, and in the end, in these systems, autonomous systems don't work very well. People really need to be part of the process with the robot. That the robot becomes an extension of themselves. And that, in fact, all their perceptions are in the robot. So even if the robot is a mile deeper undersea, or, you know, tens of thousands of miles away in space running around the moon, that the person operating the robot and cooperating with the robot is in the robot, and the sensory systems that are available to the robot really become theirs. And in fact, we get extended with a whole new kind of reach. And that's really his vision of what occurs here. That's the UAV story, that's the undersea exploration story, that's the space story. And he argues, this is going to be the driverless car story too. So we have been proceeding, and he goes through this at rich length in his book, we've been proceeding under the assumption that we're going to get replaced by driverless cars. But he argues, wait a minute, 40 years of experience with robotics says that's not what happens. Instead, this symbiosis starts to occur, right? Because people are not going to want to give up certain kinds of level of controls and certain kinds of decision making, right? They're going to want to be involved in those. So he argues that just as with undersea exploration and with the other robotics fields that he's talking about, a richer driver experience that involves much more engagement with the surroundings, much greater information and knowledge access, much better safety and much better comfort, a lower stress environment, can occur in a driverless car setting. That people will still be in command of the car. They'll be able to cede a lot of lower end territory to the robotic activities, but will retain certain kinds of charge and be able to operate in a different kind of level of perception. We'll see. You know, time will tell here. The driverless car movement has been pushed by a whole community that essentially wants to get people out of the driver's seat into the trunk, right? Or at least watching movies in the back seat. Mandela argues that's actually probably not going to occur. And then he lays out a series of technological challenges that have to happen. So LiDAR, which is the fundamental radar system we're using for driverless cars, and David knows a lot about radar because that's what his new company is organized around. LiDAR happens to be very problematic in wet surfaces and snowy surfaces. It fails, right? That's why Google has based its driverless car operation out in sunny California, right? Uber is having much more trouble in Pittsburgh, and I'm sure your friends, Steph, are going to have trouble when they worry about Boston in the wintertime with their driverless car initiatives. You know, it's highly problematic. You can get around that by using ground penetrating radar, which avoids the surface water problem, and surface slickness problem. But, you know, at the moment, that's another $70,000 per car. So, you know, the prices will get driven down the cost curve, and maybe we can do that. But these are significant barriers here. I was at a presentation recently by Gil Pratt and John Leonard, who are leading the Toyota driverless car initiative. And it was an interesting discussion. The leader of the discussion said, well, you know, we're going to have driverless cars, you know, within 5 years. And Gil Pratt, who led the whole robotics effort in DARPA, you know, and a former MIT faculty member, one of the most respected experts on robotics in the world, and named by Toyota to lead their effort, Gil had this line, and he said, you know, people tend to completely overestimate what we're going to accomplish in the next 5 years and completely underestimate what we're going to accomplish in the next 50. We're not good at making that balance. And in effect, what he was saying is the driverless car problem is not a 5-year problem. And then John Leonard, who's running MIT's part of the Toyota initiative, one of MIT's famous robotics experts, he put up a video And the video was him taking his kids to school, and they drive down a residential street in one of these kind of urbanized suburbs around here. And, and there's a T intersection, so they leave the residential street, and they have to make a left turn to get to the school. Kids are sitting in the back, right? And in the lane immediately in front of him, going in that direction, going to the right, are cars that are erratically coming across at about 40 to 50 miles an hour. And then in the lane that he wants to get into, it's bumper to bumper completely stalled. And he's got to turn left. He finally is able to solve the problem, he indicates, by rolling down his window, making a judgment about what driver might be the most sympathetic, right? Waving, establishing an eye contact, and this driver is willing to let him pull in front of her, but he's then got to wait. She's got to be at the right point of the line, and the erratic 50-mile-an-hour cars have got to let up a little bit so he can get across. He's finally able to achieve it. He does this every morning. He said, look, I can't write the algorithm for the left-hand turn into heavy traffic. I can't do it. I've been thinking about it for a long time. That is at least a 10-year problem. How is my driverless car going to establish eye contact with the driver in that far lane, right? How are they going to signal out the window, right? How are they going to make that personal connection? All of us, when we drive all the time, are making constant judgments about other drivers. John Leonard says, I can't write the algorithms to evaluate, the crazy 18-year-old hot rod driver versus me versus an elderly 65-year-old driver. Right? I can't make those differentials in my algorithms to make this thing work. So the problem of driving in an urbanized setting is going to be profound. He said, look, we can probably figure out interstate driving. The variables are much more manageable. But urbanized setting, it's really, really complicated. So I guess what Mandela is telling us, and those are just examples that are not in his book, but I'm pulling up from recent experience. But Mandela is telling us that this autonomy is not necessarily at hand, and even when it is available, and he uses the example of the moon landing, the astronauts preempt it because they see things, i.e. a small crater, that would have prevented the landing in the right location. So they have to take over the controls and move the thing. People are not going to want to give up that level of involvement, he argues, and shouldn't. Because there's some things they're going to be better at judging than even the best machinery we can come up with. So there's an example that David uses, which is that a combination of a chess master and a computer always beats another chess master alone or a computer alone, right? And so far, that's our experience. Now, all of these things could change over time, and technology will definitely advance. But what David is arguing is that this robotics revolution is not going to be a revolution around autonomy. It's going to be a revolution like this revolution around symbiosis. And I think that's a really important thing for us to keep in mind as we think about the speed which these changes are going to start to happen. The complexity is really high. And the nature of the changes themselves. And in David Mendel's world of cobotics and assistive robotics, there is much more room for people than a truly, totally autonomous system. And that presents, again, back to our education discussion, that's back to our training discussion, that presents a whole new set of ways of thinking about what this is going to look like that we probably ought to keep in mind. And it also means that the timetable of these changes is not as abrupt as the media has been telling us in the last couple of years, right? It's a more manageable, David Mendel would argue, and more gradual kind of timetable. All right, Sanam, it's all yours.
Yeah, so I think that the question about symbiosis between people and machines is really interesting, especially considering the debate about whether people and robots are like substitute goods or complementary goods. And I think that the consensus here is that they're deeply complementary. But I think that also has some interesting implications for what that could do to the human environment. So even with goods that are complementary, it's likely that this will kind of push out the demand for the types of labor that is more well-versed in and high-skilled and well-versed in working with these types of technology, and reduce demand for labor that's less so. So I think that there are really important considerations about when you're integrating technology into human environment, how it's going to affect that environment. So I think just a question that a lot of you had was when you are looking at building these autonomous or semi-autonomous technologies into an existing human environment, it's going to require a lot of knowledge about that environment in order to make these important predictive models. So what are some of the biggest challenges in doing that, and where do you see like the potential failing for pitfalls?
So one of the things I was interested in, I really agree with a lot of the points that he makes. I think he lays out a really optimistic but also like appropriately realistic future for our symbiotic relationships with robots in a lot of different fields. But to the end of answering your question, he raises the issue of the pilot, the soldier, and the astronaut, who are all to some extent a little reticent to fully adopt complete autonomy in their own like respective fields. So I guess one of the places where you could consider a potential failure of that symbiosis is that hesitation to adopt the fully autonomous system something we should train out of these humans, or should we adapt our technological like development to match that? Like, is that a failure point, or is that okay?
It's possible that the want to, or the desire to go away from autonomy, maybe they have some sort of instinctual realization that the computer cannot do everything that they can.
Yeah.
Like it's not as good as pattern recognition, that kind of thing. So maybe it's not a failure point. Maybe instead it's I'm not sure what you would call it.
It's a strength.
Bless you.
Actual
Yeah.
benefit to that.
Yeah. Almost like a warning system. Yeah.
Yeah, and on top of that, I feel like there's a whole, like, especially thinking about cars, but I mean, I'm sure for pilots and other people as well, like there's a lot of like culture around being like a driver or being a pilot. Like you like can define yourself as a pilot, and I think by taking away any control that you have over like an aircraft or something, that can be something that people don't want to do just because like people like to drive, like they like the open road, they want to feel like they're in control, and taking that away could just be like a cultural issue as well.
I thought Autopilot was like pretty well accepted and kind of integrated by now. I know, especially for like long distance flights, like, you know, cross Atlantic, like I definitely don't want the pilot of this airplane like reading and charting the navigation across the Atlantic Ocean. Like I'm good. We can definitely have you know, more integrated technology to allow machines to do that, but like at least within the pilot community, I thought this was pretty accepted. And like now with fighter pilots and things like that, like you're going so fast, it doesn't make sense to have a human interpret all these signals that are coming in. Yeah, no, go ahead.
Yeah, no, you are right. It is very widely accepted and integrated, but also I think you make an interesting point that in terms of how people define themselves and that job being actually part of their identity. Also, I think as we've developed more and more complex machines and those machines become integrated into our life, we interact with each other through those machines. So even just taking the example of like air traffic, there's a very complex communication network between air traffic controllers and different pilots in, you know, from commercial aviation to general aviation. And there's even though that system has a lot of autonomous components in it, in today's day and age, there's still generations of protocol, both very officially delineated and also sort of adopted as practice. And I think that the humans who are willingly part of that system as controllers and pilots know that very well. And so they know how to interact with the other pilots both in sort of like manners and how to make well-informed, safe decisions based on what other people are doing. So I think, I think that's even though they might be flying technically a completely autonomous plane, they still serve as the endpoint of the communication with other humans who are in charge of other completely autonomous systems.
And what
Right,
are you
and Chloe, I think you're absolutely right on that. And from what I understand from David's book and discussions with him, in addition, he gives a remarkable example, right? And it's a startling example that starts the book off. And when you get a chance, the book is really worth reading. He tells the story of an Air France crash over the Pacific like 15 years ago. Chloe, I see you're smiling, so you think you know the story. And you can extrapolate and see if I get the story right. But essentially the story that he tells is that, there's a moment in the flight, they're on autopilot. As you point out, Rashid, it can be a very useful tool for pilots and is used in many parts of a flight pattern. And they're on autopilot, and the plane enters an area of very low temperatures and ice is forming on the wings. So the autopilot system default mechanism at that point is to remove the autopilot control and switch it to the pilot control. And what has happened is that the pilot of the aircraft is back in the restroom because they're on autopilot over the middle of the Pacific. And the engineer, the flight engineer, and the co-pilot are at the controls. They're relaxing. And suddenly they're in charge. And each has a different reaction. And it ends up completely destabilizing the aircraft and throwing it into a spin right into the Pacific Ocean, where all the lives in the aircraft are lost. And they have the opposite. They're not ready. So this moment of people being ready to take control again after having been out of control turns out to be a nightmare in all kinds of other settings, right? It's very unmanageable. How do you keep the person who needs to be in overall control completely in the game, right? And how do you keep them completely involved? So that's one of the most complicated design problems for autonomous vehicles in general and driverless cars in particular, right? Since we're probably not going to get to fully driverless cars soon, how is that relationship going to work, right? And how are we going to play that out? And how do you keep just enough of a level involved? And interesting, Rashid, back to your point, the autopilot system in aircraft has actually now evolved to the point where they keep that balance right between the machine and the person and the overall personal control and the desire of the person to retain the control. They figured out what the signaling is so that that actually works well on both sides. But that's a really complicated balance to work out. Have I got that right, Chloe? Is that anything to say more on this? Are you studying this?
Well, I mean, in Aeromaster we do a little bit of like failure investigation, but I also fly like personally, and I've had a lot of experiences that validate that exact thing. So I used to fly a pretty small 4-seater aircraft, and
Let's do.
yeah, well, a Columbia, which is basically the same size as a Cessna, but a lot faster. And so one of the, I used to fly with my dad a lot, and one of the stories that we would repeatedly live out when we were landing at a new airport was that the air traffic controller would, based on the size and type of our aircraft, would vastly underestimate the speed at which we were making our descent. And a full descent to most of these airports is like a multi-leg type thing that you start, up to 20 minutes before you're actually on the ground. So it's pretty complicated. There are other airplanes in the air, you have to match their speeds and rates of descent so you don't have two people colliding on the runway. And repeatedly we would be, how fast we were going would be underestimated, and we would be coming down like, much more rapidly than the air traffic controller would think. So, we'd be going faster than like a much, much larger aircraft was. So that was just another case where establishing that human contact with other people to let them know where you were, and with the people who whose instrumentation was telling them something different. It's important to have people who know their own machines involved in the process.
I think there's also an opportunity for using autonomy in an area where there's human bias. Like there's a case study of like a Japanese flight where the co-pilot knows that what the actual pilot is doing is wrong, but because he's an authority figure, he won't contradict them. So using some autonomous things, see like, no, this is wrong. We're definitely like doing something wrong, or at least put some kind of flag, is useful. In sci-fi, like it was really cool because it talked about like human bias and justice, like when you make a decision. And so there's this one science fiction where, like in the future, like an AI was the judge because he'd be non-biased. I don't know. I think that's also pretty interesting.
That's already kind of happening, that they've been using algorithms in some jurisdictions to determine whether someone should get bail or not based on their background. So it's like a proprietary software, which is kind of scary to begin with because people don't really understand like how it's making its decisions. But you'll put in different factors about the person, and that can help inform the judge as to whether they should be let out on bail or not. And so I think there's a big lawsuit. Someone just filed a lawsuit about that, since you're not allowed to face your accuser if your accuser is an algorithm. So like we're already getting into this like
Yeah.
Why would you? Why would you even start down that road?
well, because the justification,
It's more fair.
whatever you
And it's
think of it,
faster.
is that for a lot of judges who are seeing like hundreds of cases a day, a lot of things are affecting their judgment from like, I think the paper I read said it could be like if their favorite team won the night before, or if they're hungry, like they're influenced like by these outside factors. So if we automate it, then we take out some of those biases and other biases that judges just have like inherently from whatever their upbringing.
Or like compassion, maybe? I don't know if there's a compassion.
Well, I mean, I think
I'm just.
No, like it is that. It's like.
I mean,
it's
that's
very
there
hard.
too. Yes.
yeah. I mean,
There's
also
some-
like, the way I would think about it is like, great, because you get a nice heuristic, and if there's ever an issue, that's the one that goes to court, like, and we'll get like a full thing. Because there's probably a lot of issues that are very quick cases. So, but there's a whole thing at MIT about this now that they're doing like lawyers and tech, and it's around Sloan and around the Media Lab, but it's a field that MIT is looking into, but I don't know if we'll come up with a law school.
There's a really cool study that I just read for my paper. I pulled it up. It got published literally this week by Carnegie Mellon, entitled "A Human-Centered Approach to Algorithmic Services: Considerations for Fair and Motivating Smart Community Service Management that Allocates Donations to Nonprofit Organizations." So it's a very long title, but it's essentially
Yes, it is.
3 stakeholders from CMU.
The title of your paper is going to be shorter, I'm sure.
I hope so. So there's 3 people. One of them is from the Center for Machine Learning, another one's from the School of Design, and then there's a stakeholder from an organization called Food Rescue, which serves a greater, the greater Pittsburgh area. And what was really cool about this was essentially that they not only talked to computer scientists who are designing the algorithms for who gets the food allocations, but then they also evaluated the ethos that was driving the way that that the programmers were devising their algorithm and the decisions that they had made, right? Like the cost-benefit analyses and like who actually gets the food, why they should get them, what considerations their children should have, etc. And then from there, they started thinking about the ways in which the algorithm was designed, how that would impact in implementation the lives of the people receiving the food and whether or not that was fair. And interestingly enough, and I think that this is really, really crucial in, not only the design process, but generally in policymaking, was the question that they bring up about empathy, right? Like, to what extent are the algorithms that are being created reflective of the individual programmer's ethics and personal values? And that was something that they really bring to light in this, I think, is an incredibly innovative case study, right? And it's being applied to the nonprofit sector in a really small, sort of piloted way, but I could see studies like this sort of scaling up to other algorithms and really striving to understand the ways in which they prejudice decision-making, even if they act as heuristics, right? Heuristics are just utilizing values as shortcuts to decision-making based on sort of your intuition in the decision-making process. So that could be really cool, but at the same time, for me as someone who studies both design and politics, there's an enormous, and I guess my religious studies also influence this a bit. There's a huge movement in religious studies to move away from empathy because it can be utilized as a tool for manipulation, right? Because if you have insight into what an individual matters and what motivates them to action, then that is not good. But what indeed you should have, as was stated by a divinity professor at Yale, and I think he also does some work in philosophy, is that what you should strive for, and what I think the algorithm should strive for, is compassion, not empathy, which is distinct from empathy. The difference is that in empathy, empathy, you seek to feel the way that the other person feels, where in compassion you seek to understand how they feel, but you don't truly try to access those emotions. And so I think that compassion intellectually is more sustainable and is something that you can actively implement in an algorithm, whereas if you try to make your algorithm empathetic, it starts getting into the realm of making value judgments, which is ultimately going to be damaging and more prejudicial than if an individual is making a decision, because then you can sort of leave the perjury to the machine and not place the impetus of whatever discrimination is happening on an individual.
Also hacks.
Always hacks.
Yikes.
There are hacks of people too.
The Microsoft, just quickly on that point, they just released an article in the New York Times, I think it was yesterday, on the hack that happened in England on the NHS, and they were wondering what role, or what is the role of Microsoft in all of this? Like, should they be to blame? So, question.
Well, the whole time I was watching this, I mean, Mandela he's brilliant, obviously, but I also think that I couldn't help but think that he was being a little hypocritical, because I think his whole message and premise was, don't worry about job displacement by autonomy or robotics, autonomous robots. It'll never happen because the symbiosis of humans and machines is more powerful than the machines alone or the humans alone. But I don't think that we can deny that certain jobs have been displaced or replaced by automated machines, robotics, etc. And although more jobs can be created in the future or as a result of improved technologies, we can't really get around the fact, I think, that the people who do lose those jobs often have families. And then, as we've been talking earlier today, then they're out of the game. They don't go back for a 4-year, like an advanced degree, because, oh, now I need a PhD or a master's degree. They're often permanently unemployed or displaced into other, like, service sectors. So yeah, David Mandela, you're right. We're probably never going to be completely autonomous, but then again, there are jobs. Like, you can't deny the fact that there are jobs.
I think I had the exact same feeling that I was like, I wouldn't necessarily say hypocritical, but maybe biased. He's never going to be out of a job. He's the person who invents these. Of course, he's the one who's staying ahead of the techtechnological race, because he is the technological race. You know, like the symbiosis is very real for the scientists and engineers whose limits have been extended by these types of endeavors. But for the people who have never gotten to that level of education in the first place,
he points it out, like, okay, yes, there are people in manufacturing jobs who get replaced, but it's similar to how I think it was one of the other readings where they were saying that the people who would have to light lamps in the street got replaced by electrical lights, or people who would shout news to factory workers were replaced by radios. You know, it's gonna happen. You know?
It's gonna happen.
And
but
you know,
I think
it sucks, but it happens. That's how progress works.
Self-centric view.
It's not. I don't know really what's the alternative. Stop progressing, because then other countries start progressing, and then you're left behind, and then everyone's unemployed because now your country doesn't have money. That's not good.
Also, if you don't do it here, somebody else will.
Sorry, I just wanted to make a quick point about the concept of fetishization, because I feel like fetishization. Yeah, where I feel like because I think, at least in my understanding, fetishization in postmodern philosophy is the process by which you love the idea of something so much that you relentlessly pursue it, and that you continue, operating in the pursuit of that, right? And the question that, as much as I love technology and as I'm fascinated by it, and as much as, I someday maybe want to be an engineer, right? I ask myself, like, how is it that we have come so far in autonomous vehicular technology, and we can't get more public bus routes, right? Like it doesn't seem like a trade-off to people, but to me that's an enormous concern. And I'm constantly looking up questions like this on Quora, and people are like, well, it doesn't matter because they don't have to be mutually exclusive.
Well, this is the whole problem with change in legacy sectors. How do you introduce innovation in legacy sectors? That's also at the heart of that kind of question. And changing a public transportation system, an established sector, may in many ways be far harder than introducing a completely disruptive technology that's completely outside the scope of an existing realm.
But I
Also,
So-
doesn't this fit in with what Bill was saying before, where like the city driving is unbelievably difficult, and we probably will never get autonomous city driving? Like,
Well, I'm not saying never.
well,
I'm just
it'll
saying
take
it's,
a really long time. at
this
very
is
least.
this is more than a decade of a problem.
Yeah.
But I guess I'm curious, like, why do we view these some, I'm not going to say nearly impossible, but these incredibly technically challenging problems as more solvable than getting more public buses on the route? Like, why do we have more persistence and resilience when it comes to
Because it's a
technical
frontier
innovation?
territory and the barriers aren't in the way.
Yeah, there's a
Right.
lot more barriers for making a train, how much it costs.
Right.
But I'm not talking
But
about trains,
that is-
literally public buses.
I don't know. Also,
No, I
some
think what
people
we're
use
trying to get at is like there's no like barrier to like figuring out what the new autonomous vehicle is because there's no existing infrastructure on autonomous vehicles that I have to overcome. Whereas in order to get new public bus routes, I have to like contend with the established system of public bus routes and kind of go from there. That, I think
Yeah,
it's
interesting.
There was an Uber. There was like a startup that was like Uber but for buses, which is like
Bridge.
optimized for people's.
Bridge.
Yeah.
I
Something
think they
like
just
that.
went under.
Yeah, it's just a lot of the financing. The economic cycle doesn't turn continuously.
Right.
So it needs to get spun. But I mean, a quick point. I think you brought a really good point in terms of like the people writing these papers. I was at a talk by a diplomat on like Trump in Mexico, and he used this really funny term where he's like, "Yeah, it's kind of interesting to like read a lot of these papers because a lot of them are like when tech billionaires talk about, yeah, we're gonna do this and help like the Moman or go to their dinner." He's like, yeah, they're kind of like limousine liberals, which I thought was a really funny term. Not to criticize liberals, but I think there's the people that read 10,000. There's also a Chinese saying, which is much better to walk 10,000 miles and talk to people on the way than to read 10,000 books. That I think is really true, where it's like, okay.
Are you familiar with that one, Louis? Good. I want to certify it.
It's like, oh no.
Very fine.
It's a great line, Martina. I want to use it myself, but I wanted to validate it.
I mean, I like the losing liberals, and I was like, yeah, that's pretty funny.
That's an old term. That term's
I
been
didn't
around
know.
for a while.
I've never heard of that
I've
before, but
never
it makes
heard that.
total sense.
But it does really, classify the Silicon Valley, kind of.
Libertarianism.
Yeah, but I think the big issue is like we really need to start talking to like the people on the street and like what they're thinking, what they think about the issue, rather than just like this is what it could be. Also put into practice, because in practice could be a lot of different things. And the way most people just want to do good, and sometimes their words, I'm clouded by the way I view those words. You know what I mean?
I'm just really perplexed by the fact that people will spend 50 years trying to develop a technology, but like in 2 months, right, or 2 years, you can't increase support for public transit. Like that I think is to me like what's insane about
Maybe
the public
that isn't
sector.
because of the nature of the good. One is public good, and the other one is
Right.
marketable, tradable,
Also,
private goods,
culture, like in the
and
U.S.
there's profit.
Yeah. Like,
Also, to tie it back to one of your earlier points about how we have these Snapchat-esque companies, Facebook-esque companies before we have the big players, and also because it's easier maybe now for a group of 20 to 30 scientists and engineers to make a Mars rover and for have that to be a successful mission, and to have a lot of little things like that where they can define how they want their innovation to operate before we can then take that infrastructure that is established by those pioneers and apply it to public good work.
Interestingly, Sanjay Sarma makes the argument of MIT. He makes the argument that we're not going to get to anything resembling autonomous vehicles until we integrate the systems we're developing into the infrastructure itself. In other words, suppose rather than trying to make the vehicle entirely independent of everything that's around it, people, everything that's around, right? Suppose we integrated the vehicle into a new set of smart infrastructure. So in effect, there are rails for every car, right? They just happen to be cyber rails. And that would simplify all kinds of things in the autonomy project, right?
Or like parking in a parking structure.
But it
You
also
take it
means
to a dock, and it,
right, exactly.
structure deals with
right.
it.
So in other words, making the infrastructure smart in parallel with making the vehicle smart radically resolves a lot of the problems here. And yet we haven't even thought about that. We're so busy embarked on making the vehicle totally independent that we haven't even thought about a much more logical path, he would argue, which is to upgrade the infrastructure at the same time we're upgrading the vehicles. And he argues, what's going to happen to people, right? Well, you've got a massive infrastructure upgrade, which is going to be heavy employment focused, right? It's a significant kind of offset. We haven't even thought about doing that, right? And that gets into, in a way, some of the issues that you're talking about.
Yeah, and what's interesting is that in the article that I conducted with the co-founder of Neuron Mechanics, he said that the firms that he has talked to, and Nutonomy specifically, not to, so to speak, throw them under the bus, that they don't think that those are considerations that fall in their domain. They think that the market is at some point going to decide these things for them, and so they should just worry on fixing the technology. But if there's anything that this class is teaching us, is that we need to include these considerations within the research and development process, even at the basic or early stages.
Right. So, Sanam, how about a closing thought on David Mandela? We've had a robust discussion. Thank you all.
So,
I think everybody got into it this time, too.
Yeah, I think it's interesting that this debate about autonomous, semi-autonomous technology raises some really philosophical questions. First, about when we're talking about humans' trust and agency when it comes to technology, and then also about what the goals should be of when you're talking about integrating technology into deeper and deeper parts of the human life. Like, what should the goals be? How much should there be intervention on, and like how can we improve the overall infrastructure? So I think it's just some, I think Mandela at some point talked about how this is like engineering at its philosophical best. So I think that's an interesting point.
Good point. Good closing point, Sanam. All right, one more to go. And you're back to me.
Save the best for last.
You can be the judge, Rashid.
That's a good line.
But that is the cover of my next book, written with Peter Singer. These are both Peter and I out hiking.
So he took one of you, and then you took one of him?
No, I think his mother took that picture of him. My wife took that picture of me. But this is, as you saw, a chapter that's actually going through a fair amount of revisions from the version you've got. But it's an attempt to kind of wrestle with this kind of movement here around the future of work. And, in this concept that people are going to get displaced by automation, this has been with us for a long time, right? So the first major episode is really in Britain in 1815 around the Luddite movement. And they're with weavers smashing automated looms, right, that are putting them out of work, right? And eventually a whole division of the British Army, like 15,000 British soldiers, get pulled in to put down this pretty significant movement in Britain. So that's the first episode. We regularly go through this debate about every 30 years, roughly. In 1950, I mentioned this before, but Norbert Wiener painted this very dark vision of computers displacing people. It took us a long time to evolve into Licklider's vision. In the 1960s, there was huge anxiety about workforce automation as a number of new technologies are being introduced into the industrial processes. In 2015, that concern came right back, that a mix of artificial intelligence, machine learning, robotics was going to be very threatening. This is an old debate. So the famous economist John Maynard Keynes once famously wrote, "Thus we have been expressly evolved by nature with all our impulses and deepest instincts for the purpose of solving the economic problem. If the economic problem is solved, making will be deprived of its traditional purpose." In other words, our lives are organized around our work in many, many important kinds of ways. And that's how our lives get meaning. And if we're blowing up the work model, what's going to happen, right? But the important point to realize here is there's no sign of that yet, right? The American work week is 47 hours at this point. So it's we're some distance away from this. We have time to reflect on this if we ever indeed come close to that kind of level of realization. I just wanted to expose you to this famous Keynes point, because Keynes is thinking about this in the midst of the Depression, right? He's thinking about the whole future of work. So the backdrop that we're facing now is significant work disruption, and we've talked a lot about that today. Half of the manufacturing jobs, as we talked back in class number 3, were lost between 2000 and 2010, and we saw the data on median income decline, and we talked about the barbell problem. And Brynjolfsson and McAfee paint a picture of technological job displacement and describe the accelerating round of IT technologies that are headed towards the workplace. Now, when we read about advanced manufacturing, right, the fix for the manufacturing sector is full of new technologies like 3D printing and digital production and advanced sensors and photonics and a raft of advanced materials, a raft of new technologies that are also going to be entering that sector to make that significantly more efficient and kind of get the US back in the game. That's the whole object of that exercise, right? So there is a raft of new technologies that is headed from the IT world and elsewhere into the workplace that we're all going to have to reckon with. And there are technological dystopians. So Martin Ford argues that there is a system of winner-take-all distribution that's evolving, that the technology of software towards monopoly and the ability of computers to do more than they're programmed for, deep learning as it's called, is going to push out a whole lower end. That this winner-take-all distribution is going to be very disruptive to society. David Cowan argues that the country will be divided by this technological advance into 2 countries. We'll have a developed world and we'll have an undeveloped world in the United States. And indeed, Peter Thiemann of MIT, the economist, has just written a book arguing that current inequality in the United States has reached such a level that the right comparison is to look at developing world economics in a US context to understand it fully. Just for example, Germany, the lowest 20% compared to the highest 20%, it's 1 to 4, right? In the United States, the lowest 20% of the population income to the highest 20% is now 8 to 1. That's pretty dramatic income inequality. That's different than how the US was for the previous, century. In their Second Machine Age book, Eric and Andrew argue that the low-skilled replaced the middle-skilled jobs that were displaced by technology. They argue for tax policy as a fix here, although as we've discussed, and Rashid led us into it, that politically is a very tough proposition. There are studies that project very high levels of technological job displacement. So out of Oxford, Fry and Osborne look at occupational descriptions and conclude, 47% of all US jobs have high likelihood of being replaced by automation. Rob Atkinson at ITIF has given a very strong critique of that study. He argues that it assumes a highly unlikely 3% labor productivity rate, the advent of all this automation. We haven't seen that since the 19th century, so don't expect it to happen anytime soon. Atkinson argues. They argue that Fry and Osborne engage in a lump of labor fallacy. In other words, they assume that there's a fixed amount of work, right? And that the amount of work doesn't grow spurred by these new technologies. That's what David Otter led us to understand better, this whole complementarity. In other words, there isn't a fixed amount of work. The complementarity can create more, right? So that there are larger net potential gains here across the economy. The most realistic study of technological displacement so far has been by the OECD, done last summer. They looked at 22 OECD nations, and rather than look at occupational descriptions, they decided, let's go talk to the workers that are actually doing those jobs. And this went through 22 different OECD countries. They actually went out and talked to the workforce. And they would talk to people about you may have a particular job title, what are you actually doing, right? What does your work actually consist of? And of course, it turns out, and we all surmise this in a way, people are doing many things that aren't necessarily captured in their job title. Heaven forbid if somebody held me to my job title, right? Nothing would ever get done, right? And we all know this, right? And that's what the OECD found. People are doing much more stuff than their particular narrow job description may, say that they're doing. So they concluded over an extended period of time across those developed countries, the effect of technological displacement was maybe 9%. Now that's a significant number even over an extended period of time, right? That's a significant number. But it's not 47%, right? In the United States, the number was 10%. The range was 6% to 12%, depending on what kind of employment you had in your country. That's means we have a job ahead of us, but it's not a nightmare, right? It's not something we should be, sleepless over every night from now on. There's a recent effort on, this is not in the book, but in the chapter, but Daron Acemoglu, another very noted MIT economist who does a lot of work with David Otter, and is a real student of innovation. He's a growth economist. Daron looked at robotics, and he looked at job displacement in the robotics sector, and he had a good database that he was working from. He concluded that over a 17-year period, ending in 1977, a total for the entire United States economy of technological job displacement caused by robotics was somewhere between 300,000 and 600,000 jobs. Over a 17-year period, that is not a big number, right? Job churn in the United States per week is something like 75,000 jobs per week, right? Look at it in that kind of context. So these changes are going to be significant, and I would argue, they will occur. But we may have a time period that we're able to look at them and think and plan and act, rather than being completely disruptive overnight. So there's a quote by the vice president of the Danish Conference of Trade Unions, named Nola Heldun. Her comment at a conference that OECD conference I went to last fall was, new technology is not the enemy of workers, old technology is. And what she's saying here is that the companies most likely to fail, where all jobs will be lost, are those who are not keeping up with the technology. That workers have a stake in keeping their firms current with current realities. So there is and here's a chart that just shows the rate at which robots are being installed into production. It's actually slowed fairly significantly. Now look, we're in a process of moving from old style industrial robotics, which used to weigh tons, and they were fixed in place, and they had to be fenced off because you didn't want to be anywhere near them because they were unsafe, and they would do the perfect weld, and that's all they could do, right, on an auto line. We're moving to a whole new generation of robotics that are much more flexible, that are subject to voice command, that are a radically different kind of robotics than the old industrial robotics. So some of this data may reflect the fact that new generation of robotics is only now just starting to be thought about and put together. Max?
I think that this has to do with some of the anxieties that workers have expressed around being replaced by robotics. Like there might be some sort of relation there. This
slowdown rate?
Yeah.
I don't know. I don't think so.
It just seems
because we don't have an organized workforce anymore, right? We're down to about 11% unionization in the United States.
Really?
Yes. So workers don't have a lot to say at this point in the U.S. about a lot of these changes. They don't have a lot of control over their employment, frankly, which is another set of issues. But the chapter argues that the most immediate near-term problem is not technological displacement, right? That's going to be a longer-term problem. The most immediate near-term problem is what economists call secular stagnation. And that's the problem we're in now. And this term was developed by Larry Summers in 2013 to essentially describe the situation that we've got at the moment. Interest rates around zero, and U.S. output is insufficient to support full employment. Now, he's writing in 2013, it's gotten better since then, but we do have this structural unemployment where a significant number of people who had jobs no longer are in the workforce, right? That's the problem that's still with us. He argues that there are a series of factors that affect this, that are hampering the investment demand. So decreasing population growth, right? We can all see that. A relative decrease in the cost of capital goods, excess money being retained and not used by large corporations. So retained earnings by large companies is very high at this point. On the savings side, he would argue excessive reserve holdings in developing countries due to post-crisis, in part post-crisis financial regulation. Inequality is a cause here, and increasing intermediation costs are all causative factors in this period of low growth. We have very low GDP, and we have very low productivity. So economy-wide, our productivity is about 1.12%. Not a good level, right?
Low unemployment.
Right?
But we still have low unemployment.
Yeah, we have 4.9% unemployment, but go back to Rashid's barbell example. A lot of that is the thinning out of the center being pushed to lower end services jobs.
Also, the labor force participation rate isn't too high.
Yeah.
People
So
just
we have
aren't
low
looking
productivity,
for it.
low capital investment, right? And a low growth rate, growing inequality, and a declining middle class, right? These are big problems. Now, low productivity rate, low capital investment, that tells us that automation is not happening at the moment, because automation is designed to increase productivity and is based on increased capital investment. We're not seeing either one of those. So that tells us that we're not entering a period of radical growth in automation.
So
Martine?
is this just the U.S. or is it global? And also, is it taking into account like the industrialization jobs leaving?
Yeah, it does take into account the decline in manufacturing employment. This is a U.S. picture that Summers is painting, and he's going to propose a U.S. solution in a second, which is a major infrastructure package. But it's a phenomena, the secular stagnation is a phenomena now in European economies as well, and in the Japanese economy, right? So this is a worldwide phenomena of the developed world at the moment, right? And it's a problem that you all have. You're going to have this future of work problem for sure, but now you've got this one.
Do we also have an aging workforce?
Yes, aging workforce, right? And that's a powerful part of the story too. Okay, so if you have a population increase, a 1% year population increase, that guarantees you like one additional percentage point in your growth rate. If you have zero population increase, you just pull 1% of growth out of your growth rate, out of your GDP rate, right? So that's a phenomena that a lot of these developing countries are starting to wrestle with. And China's going to have to wrestle with this one fairly soon. So here's what Summers is talking about in terms of excessive savings over investment. Look at the split between savings and investment levels. That means we're not investing our savings in the society, in the economy, right? And Summers identifies this gap.
And in 2008, it's like,
Yeah, so
where?
Yeah, it's
like right
Right,
there.
right? Well, that's when savings falls apart,
Yeah.
right? But there's still a big gap in the system. And investment hits then too. I want you to know of this economist named Robert Gordon, because you all are hanging out at MIT, and we believe that technological advance is the most powerful thing ever. But Robert Gordon paints a different picture, and you just ought to be aware of this debate. Not that he's necessarily right. But this was by far the best-selling book on economics for the last 2 years. And Gordon's book is called The Rise and Fall of American Growth. He argues that the current low-growth secular stagnation, and he uses the term, is the result not of insufficient demand, but of insufficient supply, i.e. insufficient technological supply. So he argues that the IT revolution is fading, and that we never got as much out of the IT revolution as we did out of prior innovation waves. Like, this one just wasn't that big compared to electricity and compared to railroads and some of the other big waves that we've been through. and that we're locked on to an innovation wave that is just not, at this stage, producing that much productivity growth. And he goes into enormous depth about each one of these technologies. So a complete rarity for an economist. He actually has read into the technology literature and is looking at what these inventions actually were in the second half of the 19th century and what they meant. So it's an intriguing alternative story, one that's contrary to the story that we've been telling ourselves for a long period of time. How do we fix this? Gordon says that it involves fixing societal headwinds is the best way kind of out of this box. And improving growth will depend on educational attainment. And remember when we read Golden and Katz, we talked about how a key to the historical American growth rate was that there's always a rise in increased technical requirements in the economy. And the genius of the American system, at least till the mid-70s, was that we kept an education curve between high school and particularly college education out ahead of that, right? That in turn, those curves are related to each other. That talent base, as we know from Romer, helps drive the technological base. If you get a large part of your economy out in prospecting or involved in supporting a technology advance, the whole system will do better. So when we leveled out the graduation rate at the college level in the mid-70s, right, we paid a big price in terms of ongoing technology productivity and technology advance as well. So that's kind of what he's suggesting. It's an interesting, he doesn't spell it out quite that way, but it's an interesting idea. So tackling some of these underlying social problems, including inequality, i.e. bring more people into the economy, right? All of these are fixes in his mind for getting around the fact that the IT revolution isn't quite what we hope for. Now, what do I think of that, right? Time will tell, right? We're going to find out. I think it may be, we had the rapid rise, we're on a more moderate growth pattern in the IT revolution, as we talked about when we talked about innovation waves. And we can only expect more moderate growth as a result of that, right? But we are waiting for the next big thing, right? For the next big innovation wave. So Summers' solution is to throw money in infrastructure. And, well, let's do roads. And that will help that community that got displaced in manufacturing jobs that aren't upskilling, right? That could help them. But the problem with Summers' solution, I would argue, and the chapter argues, is that it doesn't do anything to address productivity, right? Which is the heart of the problem, right? Getting that productivity number up, as we know, increases GDP, and it's a key causative factor behind the growth rate. And let's get that growth rate up, and overall economic well-being will improve, and you'll have more money to distribute, right? Let's at least get that right. But a infrastructure program that's aimed at roads and sewers, we already have a road system. We have 90,000 miles of interstate highway. We're not going to get, by repairing it, we're not going to get the innovation wave boost that the combination of building that interstate system and internal combustion engines got us back in like the 40s and 50s, right? We're just not going to get that out of it. So Summers' prescription of just doing infrastructure will help people who are underemployed, but it's not going to wrestle with this underlying productivity rate, which is really the problem at hand. And the alternative here, the book argues, is investing in innovation infrastructure. In other words, having a larger view of what that infrastructure ought to be and investing in that. All right, that's this text. And let's take it apart. Liu, it's all yours.
Well,
I'll go back to the hiking picture at the beginning.
Everybody's favorite. So, Bill, we have 16 minutes, pretty much. So, do we want to wrap up and then go back to the discussion, or?
Well, let's let you, Liu, tell us some key observations about this chapter. I agree, we're heading towards the deadline.
Yeah.
And there's some things I want to say too. But go ahead.
Yeah, we realized there's basically the competition of the technology replacement and the possible solutions that we have, and also all the policy factors that we want to take into account. And I think the technology replacement can actually be an opportunity for economies having an aging population. But at the same time, the United States facing low investment rate and low savings and low economic growth is probably problematic for this substitution to work well. So do we have so what are the suggestions that we have to just improve? Oh, maybe this is too general. Yeah, so what are the, well, let's talk about this. So in one of the suggestions saying like by reducing the number of working hours and can actually help to encourage consumption and help to solve unemployment. And how do you guys like this idea?
Reducing hours?
Yeah, reducing the number of working hours.
France has been
Yeah, I
working
like
on
that
this for a
idea.
while.
I would love that. But then I think you always have the people who, I mean, how do you enforce it and how do you regulate it? Because you always have the people who will want to work more hours to get ahead. Like, that's one of the reasons
That's what Chinese do, I guess.
Yeah, you define when people start getting paid overtime. It's not that hard. And then, make it so that overtime, as it currently is, you make it, you have to get permission from your supervisor in order to actually get those hours.
And most
right?
companies, that's already in place. Like if you're billing overtime, you need an excuse for it, and
exactly.
people just do it under the table instead. Because by billing overtime, you're admitting you can't finish your work in the normal hours, so they add it.
Yeah, or like in my field, we're not paid hourly. We're paid on the way that we are measured is in the output of publications that we have. So yeah, I didn't want to work until 1 o'clock in the morning, 3 nights last week, but I did because I had a paper I had to get out. And so what I can't imagine in my field an hour limit being in place.
Well, yeah, but that's different from like a factory job or like some sort of.
Yeah. I think cultural context is important. Just like I don't think it's very. I don't know. I don't think I work in the USC that like do less.
Right. This is not a very American solution, I would say.
Yeah. I would try to think about.
Career-driven workaholics.
Yeah, like it is very much the culture.
Well, in the future of work, one of the trends I've seen is people talking about who is going to lose jobs. And they always say that the alternative is that the people who are going to gain jobs are creatives, and that it's the creative economy that's going to gain the most from automation and manufacturing. So there's going to be really interesting opportunities in, say, virtual reality for people who are interested in producing, say, entertainment specifically for that, technological environment.
I think one of them proposed that it will be more of a job replacement in the middle class, and we'll see a higher demand for high-paid, high-skilled jobs and low-paid, low-skilled jobs. In that sense, we'll see a reduced size of middle class. So in terms of the rising demand for the low-skilled, low-paid jobs, what will be the social problems associated with that kind of future?
Yeah, I think you just highlighted a pretty important point that we tried to get at, which is kind of just this hollowing out of the middle class, but more importantly, like the economic models that we're going to have to use are not going to be now everyone's income levels are distributed, relatively evenly in accordance with population numbers, but like you have to use models from, different countries or stuff like that. It's going to be like an entirely different way to think about the economy, because we've never really had to deal with an economy where we've never been bimodal before, having to deal with like we only have low skill, low paid jobs or like high skill, high paid jobs, and on the like continent size magnitude the U.S. sits on, like I don't think we've had to deal with that before, and so
I don't think a democracy has had to deal with that before.
I mean, would you not say that early America was pretty bimodal? Like you had plantation owners and you had the bankers in New York, and everyone else was pretty poor.
Yeah, I think there were times in the later part of the 19th century where we had these kind of inequality numbers too.
Yeah, so
But
I think
we
it
got
is a
out of
problem,
them.
But
We got out of them essentially by raising the education level of the entire workforce.
And
that was
increasing
a very-
social labor protections.
Yes, and we did that too.
Yeah, that is a fundamental assumption that I think is pretty interesting. The assumption that there should be a middle class, or that it's natural for there to be, or if that's always going to be a case. Not to say it shouldn't be or it should be, just like it's interesting that we make the assumption that like the fundamental assumption that should be a thing.
I think I'd argue that that's pretty fundamental to the ethos of the country.
Yeah,
The
it's
American
like
model,
American.
yeah.
Overall, immigration occurred here, and social classes were significantly reduced in the United States from the period of founding until the latter part of the 19th century when industrialization took off. But that it was a pretty strong middle class base, and that talent base, that involved base, that citizen base, is pretty key to the ability of democracy to function. And what happens in democracy when you start to really split the society and significant inequality occurs? I'm worried about some of the signaling system we're getting on that at the moment.
I think it'd be interesting to do a comparison like another time in history.
Feudalism?
Economics or similar. Well, yeah, just to go, I mean, there'd be some key insights to probably learn from there. Because we definitely are living in interesting times.
But intuitively, like after learning economics for several years, I think raising the labor mobility is probably the one of the solutions. So how do you guys feel about like how effective would this be and how feasible would
Labor
it be
mobility.
in the event, like raising labor mobilities?
Doesn't that increase in efficiency?
And we've decreased labor mobility in the United States significantly in the last several decades.
Wait, define labor mobility in like a one line.
The ability to move up
Once-
and
once they lost their employment, they can move to find new employments, like with a new set of skills.
right. But what happens in these failing industrial economies is that home ownership is typically a family's key asset. If the community is failing because of industrial decline, that asset collapses. It's much harder for people to get out at that point. So there's been less labor mobility and interestingly less job churn in the United States in the last decade. And then there's social mobility, right, which arguably has been pretty key to this country. In other words, your ability to improve yourself, which has always been an operating assumption in the United States. You could always do better than your parents, right? And that may be coming to an end as well, right? That may be significantly foreclosed.
They've shown that this generation is worse off in real numbers than their parents were, or they're less wet food. It's like
Fortunately, we have more stuff. That's the one.
I mean, yeah, there's a saying where if you could choose to be alive today and be poor, or be like a billionaire.
We may be poor, but we got iPhones.
Like a multi-millionaire, yeah.
Snapchat.
It's like you're rich poor, right?
Yeah.
It's like, yeah, I can't afford anything, but I got my phone, I got
memes.
Well, actually, interestingly, in terms of memes representing your culture, I saw a meme last night that said, why do you think I post so many selfies? I don't have a car, I don't have a house to post pictures of, so I'm just going to post photos of my face. And I think that's like, I think that's really,
sad,
no, I think that's representative of like our social opportunities,
And the
right?
millionaire who was complaining that the reason that millennials don't have houses is because they're spending all their money on avocado toast.
Yeah, it's very it's so frustrating.
All right, so I'm going to take the opportunity to do a quick wrap up of just this class, because we did the wrap up of the overall class at the outset. But just very briefly here, Brynjolfsson and McAfee tell us that the advent of IT is going to be significantly disruptive in the foreseeable future, in the short to midterm future, and it's going to create significant technological job displacement. And David Otter, in his piece, "Why Do We Still Have So Many Jobs?" responds with a long-standing set of thoughtful economic arguments, arguing that we can't just look at the displaced jobs. We also have to look at the new complementary jobs that are coming about and the net increase in new technologies and production that will accompany these technological changes too. They create, a ground condition that may make this shift more manageable. And Otter also talks about how our economy, he looks at inequality and ties it to education and education attainment. And he argues overall that this inequality problem that's tied to our education levels, education attainment in our society. It's going to require significant upskilling of our population. And then David Mandela takes us back to what's the future of work going to look like, and takes a deep dive into what most people view as the most threatening territory, robotics, and argues that yes, there will be technological job displacement, but the relationship with robotics is a complementary one, that there's going to be a human-machine symbiosis. It's going to be a more complicated picture than just straight technological job displacement. There will be new opportunities for people in this mix. And then reading from the chapter of the upcoming book that I'm doing with Peter Singer, looking through the literature, we conclude that the jobless future is not on us today. And the rates, low productivity rates and low investment rates suggest that it's not evolving rapidly, right? So we may have a little time here. And then meanwhile, we do have this deep problem with a low growth rate, a low productivity rate, a low capital investment rate, which is creating secular stagnation in Summers' terms. And that's something that we need to get on, right? Because that's the immediate future. So, and then overall, this general upskilling of the workforce serves both purposes. So let's get on with that.